day, everyone. I will be discussing some methods for seed post-harvest. Seed post-harvest comes as very challenging since germination and vigor are very much more sensitive attributes and difficult to preserve. Several factors must be strictly considered when drying, storing, and transporting. When seeds deteriorate, negative impact is evident on its germination and viability that when significantly low would render seeds to be completely useless. Post-harvest methods for drying, storage, and transport of seeds must be carefully selected to maintain its germination and vigor to specific period of time. The methods should not have a negative impact on seeds as well as the cost of operation must be also reasonable. This includes requirements for equipment and energy. Here are some terms that we encounter for seeds. Seed germination starts with the uptake of water by dried seeds and ends with the emergence of a new and young plant from the seed growth. While seed vigor determines the potential for rapid, uniform emergence and development of normal seedlings under a wide range of field conditions. Loss of seed vigor is related to a reduction in the ability of seeds to carry all out the physiological functions, which is also physiologically aging or deterioration. Seed starts to deteriorate even before harvest, during processing, and even during storage. Seed viability is a measure of the suitability of the seed batch to produce a satisfactory crop. During testing, dormancy must be broken before viability can be measured by germination. When seed fails to germinate under optimal condition, then it is considered as a non-viable seed. Some of the post-harvest processes that needs to be addressed to maintain seed quality include drying, storage, and transport. After harvest, seeds commonly contain high moisture contents which are inadequate for safe and effective storage. Hence, drying process is required to reduce seed MC to preserve the physiological quality of seeds and prevent chemical and physical changes during storage. When drying seeds, various factors must be considered. Drying air temperature impacts the seed's germination directly. A study by Philho et al. Published last 2016 concluded that an increase in the temperature of drying above 40 degrees Celsius affects soybean seedling performance, and this effect is intensified over a period of storage and observed on root growth. These are the importance of seed drying: maintenance of the viability of seeds, long period storage, and prevention of mold growth and damage. These important purposes can be achieved by making sure that safe moisture content is obtained by proper drying to preserve seed viability even for long storage period. Uneven drying must be avoided because of the resulting uneven moisture in the stock of seeds, which could possibly include seeds with high MC. High MC seeds favor mold growth, which greatly affects seed quality with decreasing seed germination and vigor. When seeds are improperly dried, there is a decline in germination rate in seeds, prevalence of mold growth, and uneven moisture content compromising the quality of stored seeds. The main objective of seed storage is for preservation by considering suitable condition to avoid seed deterioration and maintain seed quality into an acceptable level for a certain period of time until they are ready for planting. When seeds are stored at ambient conditions, it responds to changing relative humidity, temperature, and presence of oxygen. Hence, several problems are encountered during seed storage, including seeds are sensitive to changes in moisture. It is also sensitive to prolonged exposure to oxygen. Seeds are very susceptible to insect attack and damage. All of this results in loss of germination and viability. Seeds with high moisture exhibit high respiration rate, susceptible to deterioration, bulk heating, favors molds and insects, and prone to damage during handling. Seeds must be properly dried up to safe moisture content for storage. However, in tropics, temperatures are high as well as relative humidity or the moisture present in the air most of the year. At an RH of greater than 65%, molds will start growing. That is why seeds must be protected from surroundings of high relative humidity. Though seeds are dried properly, the method storage must be carefully considered. The graph shows how air moisture is absorbed by dried commodity for a certain period. This commodity is placed in ambient condition using perforated PP sacks as storage. With this phenomena, seeds must be properly stored to prevent absorption of moisture from the surroundings. When seed RH reaches 65% or higher, it is now prone to mold growth and deterioration. It is important to address issues on mold growth because of its impact to germination and vigor of seeds. This also results in low emergence speed index, seedling stand, and low length and dry mass of aerial parts and roots. Mold proliferation results from storing seeds with high moisture content or storage method that exposes seeds to surroundings with high RH. When storing seeds, one has to consider a technology that will at most protect the seeds from possible mold growth by providing a barrier against entry of moisture from the surroundings saturated with moisture. Insect infestation increases chances of mold growth and contamination and also affects germination and seed vigor. Insect damage are brought by various insect activities and results of these activities, some of which are presented on the next slides. Insects can be internal or external feeders. Internal feeders are insects, larvae that feed entirely within the kernels. External feeders feed on the outside of the grain or seeds. They may also chew through the outer seed coat and devour the inside. By feeding, insects inflict damage to seeds. Some of these insects feed on germ, which damages the seed's germination and viability. When the seeds are already broken because of insects, exposure of the damage favors infection due to bacteria and fungus. Respiration of insects also causes temperature to rise in certain spots. This results in hot spots, which encourages fungal growth and further stimulates seed deterioration. With this, insect control must be in place whenever there are plans of storing seeds for a long period. Storage must include mechanism that provides hurdles against insect survival. Insect control measures must not result in developing resistance of insects against chemicals, which is also a problem because it is becoming more difficult to control and eliminate the insects, which causes severe damage to stored commodity, including seeds. Continuation of discussion about seeds will be included on the second part. Topics to be further discussed will include oxidation on seeds, how hermetic technology works with preserving seed quality, and some success stories in the field. This ends part 1 of the seed post-harvest. For more information about post-harvest solution, please visit www.grainpro.com. Thank you for listening.